Introduction to limits, true? Okay. Our job is not only to figure out the introduction to limits, grading the homework, going over any questions that you guys have. This is the example that you started off in the back of your homework spiral, bell work. But we also need to get into section 12.2 at least a little bit. More techniques for limits. Is it frozen? No, it's not. More techniques for limits. Get into that one. Oh, and did you guys see this whole algebraically direct substitution? Plug it in, plug it in. Didn't we just do this in section 12.1? And wasn't I saying something about plugging it in for this example? Because how was I able to say, actually this is a good question, how was I able to say for you guys that these were nicely behaved? Is f of x always nicely behaved? Can someone tell me a place where it wouldn't be nicely behaved? Yeah, if x equals 3, I'm in trouble. If x equals 4, it's okay. It's negative, but it's all right. But 3 is not good. But is it okay everywhere around 2? Yeah. So we're doing more techniques for limits in section 12.2, but we're starting off with plugging in, and you can always plug in as long as it's nicely behaved. Ooh, I don't remember the deadline for homework 68. When is it? May 6th. Okay. That would make sense. So when you guys went to go ahead and do things like letter A, the limit as x approaches 2, could you have made a table? Yes. Could you have looked to a graph and traced and gone closer and closer, 1.9, 1.99? Yes. But it's nicely behaved. You could just say 2 over 3 minus 2, which ends up being 2. Dun, 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 dun. A. If you got it, give me a thumbs up. Woo! Letter B. Now x is approaching 2 for g of x. Is g of x nicely behaved? Hey, do you guys know what's going on with sine? Does sine ever not nicely behave? Does he have any jumps or holes or vertical asymptotes? Nope. So he's going to be nicely behaved for all real numbers. This guy was good everywhere but his vertical asymptote. That guy's good everywhere. So either way, we can definitely plug in. I guess we could do pi times 2, but is it okay if I do 2 pi to make my brain a little bit nicer? 2 pi. Weren't we just doing the wave, or wasn't I just doing the sine wave? Where does sine start? In the maximum displacement or in the sinusoidal axis? Yeah, it starts in the middle. 2 pi, where is sine back to? The middle. And what's the middle value? 0. Just giving you a different way of thinking about sine, because if you know sine's picture, isn't sine 0 here? Isn't sine 1 here? Isn't sine negative 1 here? Now, at like the pi over 4 and pi over 3, pi over 3, pi over 6, it starts to get dicey. But at least for zeros and ones, the picture can help. Kyle?
Do you want the 0 or do you want like a real number? What 2 is? Because it's not 0.
What is it?
It's 0.1094.
What's E? Are you in degree mode or are you in radian mode?
I'm in degree mode. Because your graph wasn't working yet.
But wait, what would now pause. There have been pi's that have been degrees before. So what would need to be there for the degree mode to have been right? What's missing? The degree mark. If this is an angle, it needs a degree mark to be a degree. Now, I did see someone who was studying, I think it was Lorenzo, who was studying for his SAT math subject test for tomorrow. Subject test. And they had some weird, like, stop with the pop-ups. They did this for radians instead of, like, weird, right? They put, like, an R in the degree space for radians. I had never seen that before. Ever. He was like, what is this? I'm like, It was a problem that was talking about radii, so I'm like, maybe they made the radius a capital R, and they're talking about powers. And then finally we figured out that, no, that was 2 radians and 1 radian. And I was like, oh, it's 2 radians. That's the right answer because of the math that we were doing. So, okay, some people do put like a little R for radians, but no, we don't do that. That's awkward. If there's nothing there, it's a radian. Whoop! Letter C. Thanks for bringing it up, though, Kyle. Letter C. The limit as x goes to 2 Oh no, this is going to be awful. So much work. I have to plug into F and I have to plug into G and I have to... Why is the answer 0? You already did him, and the property says if they're well behaved, you already did him, you know it's 2. You already did him, you know it's 0. As x approaches 2, whoop, whoop, double checking. There we go. 0 times 2 is 0. Well, that was a lot easier than it could have been. How about letter D? What are you supposed to do? The limit as x approaches, oh, not 0. That would have messed everything up. I would have been having to go back to the beginning. Okay, of G minus F. What do you guys got? Negative 2, because 0 minus 2, right? I can just, according to my properties. Which limit? If they had made another part and they wanted to be tricky, if you had understood A through D, what question could they have given you to make it just a little bit harder? G divided by F would have been a little bit harder, but shouldn't you know 0 over 2 is 0? F divided by G. Oh, that one would have been interesting. What would have happened if we had done F divided by G? What did 2 now become since we would have 2 over... Ooh, what is 2 of this function if you get a number over 0? It does not exist, but how? The function does not exist, but how? Oh, so we'd actually not write equals. We're not going to write equals and then a non-existent number. If we were to do that, we would just say DNE. So hold on, let's figure this out. So f of 2 over g of 2 is equal to 2 over, that's true, which means f of x over g of x has a vertical asymptote at 2, right? So a vertical asymptote at 2. Do you guys realize I'd have to take this quite a bit further because I have to figure out, you know what, is it going together to the vertical asymptote? Is it going together to the vertical asymptote? Or is it going opposite? Wouldn't they be very different answers? So somehow, if this was the case, I would know it's a positive infinity if they agree, or a negative infinity if they agree, or a, what would the limit exist this way? DNE, or a limit would not exist if the limits did not agree, right? Okay, anyway, but we would have to go ahead and go back to the beginning and then start plugging in things like 1.9 and 1.99, and we haven't really learned how to do that whole to infinity by plugging in yet. You've only been plugging into what kind of functions? Well-behaved ones, nicely behaved ones. So we'll get to the not nicely behaved ones in section 12.2 when we get to the more techniques. But for right now, boop, let's grade. Section 12.1, let's grade. Let's grade the evens. Section 12.1, let's grade. Let's grade the evens. Yeah? Go team. Whoa. Just kidding. Everybody okay? Is the pen okay? You guys? Question, why is there a question mark in the first table? You were supposed to be looking at the table to make the conclusion. Guys, do they match? Look at your shoes. You know how to match. Do they match? Yes, 1/3. The limit exists. The limit is 1/3. Did this even make a difference? No, we were using a table. But what would happen if we plugged in? Wouldn't it be 0 over 0? The 1/3's not there, but it's okay. The limit still exists. What's going on down here? As you came from either side, did it match? Yes. But what is it? P.S. This one was a tricky one. I would never want you to use a table on this one in real life, like as we learn more. So you can put a little star by this one and be like, it's okay. There's going to be an algebraic way of doing it that we're going to learn today or tomorrow with more techniques for limits as far as plugging in, how to do that sort of thing without a table, without a graph, how to work by hand to get this answer. But the answer is -1/16. If you plug it in your calculator, you'll see the decimal looks quite similar, and that's truly what these limits are converging to. Why is there a question mark? Plug in 2. 0 over 0. Oh. It doesn't really go there, but it's okay. The limit still exists because they match. How about this guy? Did they match? No, he's 2.00 and he's 1.999. Okay, where are they both going? Oh, good. The limit exists and the limit is 2. But I know, but that doesn't make a difference, right? The limit is 2 because they match. Are we doing okay? Okay. How about number? Ooh, the rest of them. Do you guys need a little bit of time to check and grade? I think so. Let me give you a moment to check and grade the rest. I think these are the rest of the evens. I kind of packed them all so you can see them a little bit better. Yeah.
So for 34, when we put the find what the limit equals,
Yeah.
when I did this, I went to trace and then plugged in, I typed in -1, and then it showed the decimal form of ln8.
That's okay. I just put in parentheses ln of 8 because it's actually a well-behaved function. So now that we've learned that, you could just plug it in.
Okay.
Does that make sense? But yeah, it's okay. You were using your calculator. No, you're okay.
That, because it said 2, and I was like, -1.
You're good. I just put it in parentheses so your brain knows it and be like, oh, you could have, like next time you can just plug in. You guys seeing the plugging in ones on the right? Okay. All right, good? I think that was enough time. What questions do we have? Anything? Gavin actually asked a really good question on this one. Can I just pause for a sec? He got the decimal equivalent. Some of you might have thrown in ln of 8 just now to see if it's the decimal that you got, as he was using his graphing calculator. But now that you guys have learned the direct substitution trick, do you see how you could have just plugged in -1 and gotten 8 without even using your calculator? Now, I know they said use your calculator. It's okay. It's okay. The decimal's okay. But if I were you, I'd put in parentheses, oh, it's just ln of 8. I could have just plugged in, just for future reference. Yeah, Adam.
So you know how like the limit has to go from both sides?
Good.
Or either side?
Mm-hmm.
34.
Mm-hmm.
It's just kind of confusing.
Mm-hmm. Pause. I see it. Does anybody else know why Adam's a little confused on 34? If he just said a limit has to come from both sides? He's looking at ln and he's like, there's only one side of ln, right? Now, can I show you guys, this is really crazy and kind of off topic, but it actually really applies. Have any of you guys heard that the AP calculus kids took a big old exam recently? Like their big old mock exam? Okay, and they just got all their scores back yesterday and they're all kind of like, some of them are like, I guessed right. Anyway, either way. Okay, can I show you an example that they got wrong? Most of them, the majority of them, got wrong on what we call an FRQ, a free response question in calculus. Let me show it to you real fast. Because it actually, Adam, will help address the exact question that you have. Adam's saying ln only can come from one side. ln only has a domain on one side. And to that end, he's a little confused as to, wow, I have so many. Hold on, let me get rid of all these windows. Okay. How can the limit still exist? Because we've been talking over and over and over again about how we need to come from both sides. So I'm actually going into their Google Classroom. You can see what I'm doing. Nope, just kidding. It's not going to be. Is it? Hold on, let me see real fast. I put down an answer key for their mock exam. Every year I do new ones, different ones. I think it was this one. Let me see if I can find it. Do they show? Oh, they don't show the question. That's not going to help you guys. Okay, hold on, pause. Never mind. Coming back here and having you guys look at the ln graph for a second. It was a limit problem. The entire FRQ was not a limit problem. No way, Jose. But one little part of it was. And it was one little part that even my Calc BC kids, because they helped me by grading the Calc AB long answers, and it gives them good practice, and they're reviewing because on the BC exam you have to know AB stuff and BC stuff. But they were like, why do the kids keep putting this as an answer? And they were just so confused trying to figure out how on earth AB was messing up on this. It's right here. Okay. Let me have you guys be looking at this graph, okay? Look at this graph for a bit. Just ponder it. Just think about it. Don't stress about all the stuff that's going on down below. There's an integral and all this crazy stuff. Integral, wait a minute. Integration, we talked about that word the other day. Doesn't mean we can actually do most of this problem. But I want you to look at that graph. You see it? Okay. Do you see how there's like some issues going on at 6? You see that? There's some funny things going on at 6. True? This one part of the FRQ actually asked them about limits. You guys see it? Okay. Now, I know it's not going to really make tons of sense for you guys in the sense that they actually asked for the limit of this dude called G prime. And you're like, who's G prime? P.S. It's a derivative. Derivative. Tangent line. Tangent line. We talked about that. Anyway. Boop, 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 boop. For right now, let me just show you how they were confused. You can't fully understand this question or how to answer this question right now unless I say something about, hey, don't stress. This is really just talking about slope. Find the limit of slopes. I don't want to go too crazy into this, but a lot of them kept on answering 6. 6 or DNE. And this kind of has to do with your question. Ready? Adam was asking for what we were just grading in our notes. He was saying, I can go back to where it was. He was saying, wait, ln only has one side. There's no two sides to ln. If you guys look at the ln graph, it's just here, because we know that, right? Doesn't the domain need to be x is less than 7, because I need this to stay, right? Domain. I need 7 minus x to stay greater than 0. Otherwise, ln doesn't exist. There's this whole ln domain problem. This one, a lot of the AB kids were like, oh, it's discontinuous, it's broken at 6. So they would either just answer 6 for one of these, oh, hey, from below, from above. Anyway, they would just answer 6, or they would be like, it's broken, DNE, DNE, DNE. Here's the problem. Where's the limit say to look? It's not even saying to go over to where there's a problem. It's saying, no, just check out here. well-behaved can occur at points that are very close to non-well-behaved. But all I need to worry about is the area, the region right around. So where should they have been zeroed in on? Right here. But where did a lot of them get distracted? Here. So check out the one that Adam just asked. Is ln only coming from one side? I mean, it has a restricted domain, but where am I looking? Around -1, are there any problems? Exactly. So for a limit, yes, either side, either side, either side, but either side of what x is approaching. I don't have to worry about problems somewhere else. There's a life lesson in here somewhere. I can just kind of focus in on what I need to worry about. Yeah? Can't solve all the problems of the world in a day. And this problem is specifically saying, don't look there, look here. And this, the kiddos that made the video for this, were telling them, anyway, I need to go back and listen to the explanation because it's pretty funny, I think, as to how hopefully they had grace. But it's like, why were you looking there? The limit says, look here. What's wrong with you? Anyway, they didn't put it that way. But they were all getting distracted over there. Not all, but the majority of them. Well, as I come from below, right? The below is left, right? Okay, as I come from below, the answer is, I said slope, right? Down 2/4, so -1/2. As I come from below, what is the slope of all of this stuff? -1/2. The slope of all the below is -1/2. Now, as I come from above, this gets a little bit trickier, of g prime of x. Do you guys remember how we talked about that slopes of graphs are going to be tangent lines to points? So then we have to think about at 3 and at 2.9 and 2.5 and 2 and 1.5 and okay. I know usually you go right here, but this one's a little bit harder. This one was easy because it's like, oh, all of them are one slope. That's easy, -1/2. But here, this slope is what we call a horizontal tangent line. This slope is 0. Isn't it negative? More negative? More negative? More negative? Can you guys see what's happening as I inch up? More and more and more and more. What slope does a straight line have? Oh, no. That's 0. I can ski that. This is undefined. I will die if I ski that, right? So it's going to undefined but negative undefined. Boop. Dun 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 dun. You just solved a AP Calculus free response question. You can be like, I know how to do that one. Anyway. Hey, 1 out of 108, that's something, right? Anyway, there's 108 total points, 54 are free response points from different questions. Oh, you might get 2 points actually for that one because of the 2 different answers. Maybe you get 2 points out of 108. Anyway, any questions on homework? Sorry, we got totally distracted, but that was a great question, and it's an excellent one that my calculus kids needed to hear this year. Anything else? 39? I think that's right above here, right? Nope. Other page. Falling rocks. Limits have applications. That's fun. Okay, sorry, coming back. Bloop, bloop. 39. Hey guys, what would you think of doing for 39? Now, I know there are directions, and probably it's important to use the directions and use a graphing utility and blah, blah, blah. Does a limit exist? But didn't you love the direct substitution thing? Okay, so if you love the direct substitution thing, what would you maybe try to do, even though it says to go to your graphing calculator? Plug in. So if you plug in, 1 minus 1 over, this might be bad, 1 minus 4 plus 3. It's a hole. But did any of you guys get the trick or the hint or the clue from yesterday with holes? We did it once with that whole 12 one when my graph was okay, but not perfect. What kind of discontinuities are holes again? Guess what this equals? 1 over 1 minus 3 is negative 1/2. Ha-ha! Quicker than you guys could go to your calculator. But, Tony, I understand. You were supposed to go to your calculator. So how could you have figured this out on your said calculator? Well, my guess is it says use a graphing utility, so probably graph, huh? Okay. So when you go to graph, bloop, 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 you are trying to graph x minus 1 over, keep me honest. Ooh, let's zoom out. That's a little intense. And it's not focusing. It's a little fuzzy. Well, awkward. Okay, so you do your, there he goes. He's trying. X minus 1 all over x squared minus 4x. That didn't work well. Delete, 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 and I have to go down again. X squared minus 4x plus 3. Okay. We're supposed to be going around 1. I'm going to do zoom standard. I always reset just to kind of get an idea. I'm supposed to be going, ooh.
Whoa.
Limit as x approaches 1? There's some awkward stuff going on at 1. Okay, that's fine. Let's zoom in. Someone asked me the other day, like, hey, is there a way to see your hole in your calculator? I don't think any of your calculators, technically, y equals 0. What's going on? I don't know. I don't know where I am. I'm trying to zoom in, but maybe I'm not trying to zoom in. I thought I was trying to zoom in. Somewhere around the 1. That's fine. Bloop, 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 bloop. Do you see a hole? I don't see a hole. Why don't we see holes? We just said there's a hole at 1. 0 over 0, right? Do you guys remember how much space I said that 1 actually takes up?
A sliver.
A sliver. Is this showing me a sliver? No, because even my little pixel marker is taking up more than a sliver, right? Now, could you do trace and could you plug in 1 and say, who are you? Ooh, it's not there. It's empty. It's gone. It's DNE. But how do you figure out the limit? Well, Tony, I think I would have remembered shortcut the trace button. I think I would have done like a 0.9 sort of thing. And then I would have done like maybe a 0.99 sort of thing. And I see negative 4.9. Then I would have done like a 0.99999 sort of thing. I think I see it going to negative 1/2. Then you could have come from the other direction. But looking at the graph, do you see how they seem to be converging at the same height? So I think I could have just made that conclusion. But I don't know about you guys. Personally, I like this way a lot better. And that way is exactly what we're going to cover. Ooh, that's a good question. We'll come back to it, though. Too much fun today going to calculus questions. We need to go to section 12.2. Because 12.2 says, what if direct substitution doesn't work? Maybe we should try another method. What should we always try first? Direct substitution. But what if direct substitution gets me a non-existent answer? We have seen in last section, in section 12.1, just because the function does not exist at a point does not mean the limit does not exist. We have to consider the approaches from one direction and from the other. Because if the approaches match, even if f of c does not exist, well, the limit might still exist. If f of c does not exist. So if plugging in does not get us an answer, then we try something else. And there are multiple something else's. The first something else is number 2. So strategies for finding the limit. Dividing out. Diving out. Well, I bet some of you could dive out of this classroom if you needed to. Oh dear. Shh. Troublemakers. Oof. I love how he looks at me with a smile. Multitask, Kyle, multitask. Kyle, multitask. Kyle. Multitask. By the way, Gavin, looking out for his best interest. Or maybe self-preservation, looking out for your own. That's funny.
That's just when Star Wars or Avengers comes up. That's when I should be there.
All right, crazies. Focus, focus, focus. It's okay. We just recorded how much Kyle's out on his phone. Mm-hmm. And they'll be like, oh, that Kyle. Whoever that kid was. You guys got it? We are finding limits algebraically. Algebraically means by hand. And for some of you, you're like, thank goodness I was getting tired of going to my calculator. What? Tired of going to our calculator? It's a glorious day. Only took us till chapter 12. Wasn't plugging in homework so much better than going to your calculator and doing a table or a graph?
Yes.
Exactly. You are preferring to do it by hand than to use the calculator. Mission accomplished. Well, we have to do some more, though. Because there are some problems yesterday that you wouldn't have known how to do. Remember that nasty -1/16 one?
Yoinkers.
Not decimal, -1/16. I mean, it was the number, but it's okay. We'll see it. So what's going on? Finding limits algebraically, graphically and numerically, using graphs, using tables, numerically tables. Can be a backup plan. You can be like, I don't know. Okay. See if the calculator works. But we are trying to do it algebraically. It's so much easier. So we saw yesterday in the homework direct substitution. Yeah? Plug it in, plug it in. If it works, booyah, you're done. But now it's what if they don't? Dividing out. Okay, so direct substitution. Ready? If direct substitution gives you a 0/0, that was brief. If direct substitution gives you a 0 out of 0, here's what I want you guys to write. Now, we have to kind of change our notation, the AP graders. I'm thinking about the AP test next year for you guys already. Yes.
Dude, you're so kind.
Been thinking all year. Anyway, 0/0. 0/0. The AP guys get mad when we put equals 0/0. Because remember how I said the function could not exist, but the limit still does? So if we say a limit equals 0/0, and then we go on to say it equals a number, does that logic match? No. 1 second we're saying it doesn't exist, the next second we're saying it does exist. It's like some weird person who's debating and has no clue what they're talking about. I'm using the illustration of debating because it's been quite the hot topic this year. Anyway, so 0/0. We'll talk about notation later. But if you plug in, and if you're probably going to have some sort of f of c on top and some sort of g of c on bottom, and that you're plugging into the top, plugging into the bottom. If that equals 0/0, if the function does not exist, I'm going to have you write keep going. I'm going to have you write keep going. Wait, literally? Anytime you have a 0/0, I'm going to have you write keep going. Go up to a calc kid and be like, what should you think if you see 0/0? And they better tell you, keep going. They might say L'Hopital's. If they say L'Hopital's, they're smart and it's good. But keep going was what they learned first. Took a whole semester to get to L'Hopital's. Don't worry, next year they can be like, ugh, if only you knew L'Hopital's when they're trying to help you with homework. Just deal with it. It's okay.
And then we get to hear them teach us from the mock AP.
Yes. So, L'Hopital's, no, sorry, keep going. You can't do that yet. We need like a whole year before that. Keep going. How do you keep going? Here, use factoring or polynomial division to simplify f of x. Why? Because you have a hole to remove the removable discontinuity. Now, dividing is not the only way to remove holes. As functions get more complicated, as you get like exponential functions and square root functions and trig functions, dividing and factoring doesn't always remove the whole. But dividing and factoring works great. Great for polynomials. Now, here's a struggle. I don't mean polynomials as in like an ax squared plus bx plus c. I mean like a rational function with polynomial numerators and denominators. So polynomials are the guys up top and the guys down bottom. If we could just factor them enough, we'll remove the whole by division, by factoring, and reducing. So we're trying to remove the whole because remember how the other day with that 12 that you couldn't quite tell was a 12, was it a 10, was it an 11, was it a 14? How bad did Miss D make her graph? All we had to do was factor, cancel out, plug in, and say, what if we ignore the whole? What would have been there? Ooh. Okay. Moving on. So, boop. What if you have this? What do I want you to do? Plug it in, plug it in. If you plug it in, right? I could say the limit as x goes to -3 of the top, x squared plus x minus 6 is 0. I could say the top is 0. That's true. The limit of the top is 0. Limit properties, right? Take the limit of the top, limit of the bottom. Or this can come from the limit of the top, limit of the bottom. So limit of the top, limit of the bottom. 0 over 0. So what do I think?
Oh, keep going.
Keep
going.
going. Wait, I'm serious. Did you write the words keep going? I will take off points if you don't write the words keep going on a test or on a quiz or even maybe on your homework. I'm literally, we have to write K-E-E-P space G-O-I-N-G exclamation point. That's way too many characters. Okay, fine. Then K-G.
Is the case you ask the question? Right.
4 characters instead. Keep going either way. I literally want you to write keep going. Why? Because you're not done. Why? The function does not exist. This rational function does not exist, but the limit does. Why? There's a hole. But the approach, they're approaching the same poor little closed down, burnt down, whatever, in and out. Yeah? The limit exists. And how do we figure out where it is? We remove the hole. And how do we remove the hole? We factor and we say, oh, hey, aren't you x plus 3 times x minus 2? And aren't you x plus 3? And oh, hey, I could rewrite you as. Can I find the limit of the bottom one by direct substitution? Yes. Could I by the top one? No. Why? Because it was a DNE answer. But the limit did not exist. The limit did exist. And the final answer is -5. Dun, 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 dun. Woohoo! What have we learned today? You better review factoring.
Keep going.
What are we going to learn tomorrow? How do we do the square root guys and the complex fraction guys and the trig guys? Bye. Whoo, I'm just having fun. Later. This homework not due tomorrow. Probably due on Monday.